The quotient rule is used when we want to take the derivative of a rational function or a fraction. So what I've given you here is the formal definition of the quotient rule. However, there's a different formula I use that helps me memorize. So instead of writing the derivative of f of x over g of x, I write it as the derivative of the high part of the fraction, which means the numerator, over the low part of the fraction, which means the denominator. And then I write the formula as low d high minus high d low over low squared, where L stands for low, or the denominator, H stands for high, or the numerator, and D means take the derivative of. So let's apply this. I want to take the derivative of 5x minus 2 over x squared plus 1. So here, this is going to be the high part, and this will be the low part. So my derivative is low. D high would just be 5 minus high. D low would be 2x over low squared. Now, I can distribute in the numerator, and I might find some like terms to combine, so we want to do that to clean this up. In the denominator, I don't really want to multiply this out, because if I do, I'm not going to find any like terms to combine. It's not really going to do anything for me, but we always want to simplify the numerator. So I'm going to distribute this 5, and I'm going to distribute this 2x, and I'm going to wait and distribute this minus as the last thing I do. So when I distribute the 5, I get 5x squared plus 5. Then I get minus 2x times 5x is 10x squared minus 4x over low squared. And now I'll distribute the minus, and I get 5x squared plus 5 minus 10x squared plus 4x over low squared. And I see I have some like terms to combine. 5x squared minus 10x squared is negative 5x squared plus 4x plus 5 is my simplified final answer. Let's try another one. Now, when I look at this function, I see this negative 3 out here. It's just a coefficient. I'm going to go ahead and distribute it. It's going to make the function easier to work with. So this is actually negative 9x plus 6x squared over 7x. So this is my high. This is my low. My derivative is low. D high would be negative 9 plus 12x minus high. D low would be 7 over low squared. So we're going to distribute. And I get negative 63x plus 84x squared minus, I'm going to save that to distribute later, negative 63x plus 42x squared. And this time in the denominator, I just have a single term, so I'm going to go ahead and square it. I get 49x squared in my denominator. Now I'm going to distribute the subtraction here, and I end up with negative 63x plus 84x squared plus 63x minus 42x squared all over 49x squared. And I see negative 63x plus 63x will go to 0. And I'm going to get 84x squared minus 42x squared. Well, that is just 42x squared over 49x squared. And this will simplify. X squared over x squared goes to 1, and 42 over 49 will actually simplify, and we end up with 6/7. Now, I want to go back and look at the original function we were working with. For this function, we only have a single term in the denominator. By that, I mean I don't have more than one term separated by addition or subtraction. When you have a single term in the denominator, almost always the end result will end up simplifying. And sometimes we can simplify before we start the problem and make it much easier to work with. In this case, I can split my function into two fractions and write this as negative 9x over 7x plus 6x squared over 7x. Well, that just reduces to negative 9 over 7 plus 6x over 7. And if we take the derivative of that, well, the derivative of negative 9/7 goes to 0. And the derivative of 6/7 x is just 6/7. Now that was a lot easier to work with. Let's try another problem. In this case, I do see that there is a single term in the denominator, but there's no way for me to simplify the function before I start. So this is my low, this is my high. Let's apply the quotient rule. Low is t cubed. D high is negative sine t. Make sure you put parentheses around this, otherwise this negative here is going to look like a minus sign, and that would change the problem significantly. So I have low d high minus high d low would be 3t squared all over low squared. So if we clean up the numerator, put the negative coefficient out front, I have negative t cubed sine t minus 3t squared cosine t over t to the 6th. Now, what I said on the last problem is when we have a single term in the denominator, usually the function will simplify. That's going to happen here because I can factor out a t squared from the numerator, and I get negative t sine t minus 3 cosine t after I factor it out over t to the 6th, and then t squared over t to the 6th just becomes a t to the 4th in the denominator. So my answer does simplify, and we get negative t sine t minus 3 cosine t over t to the 4th. Okay, let's try another problem. Now in this case, I do not have a single term in the denominator. I have two different terms. So there's no simplifying to be done. Here's my high, here's my low. My derivative is low d high. Well, the derivative of e to the x is just e to the x. That doesn't change. Minus high d low. Derivative of the denominator is 2x over low squared. And if we clean up the numerator, I will get 2x squared e to the x plus 2e to the x minus 4x e to the x. None of those are like terms. They can't be combined. Nothing will factor out and simplify, so that is my final answer. Okay, so let's do a tangent line example. We want to always bring the derivative back to what does it mean. The derivative is the slope of the curve, and if we do it at a specific point, we can write the equation of a tangent line. In order to write the equation of a tangent line, I need to remember that the equation of a line in point-slope form is y minus y1 times or equals m times x minus x1. So I need slope, which is the derivative, evaluated at that point, and I need an x1, y1. Well, we were given the x. We need to find the y. I find the y by plugging into the original function. So if I plug a 4 back in here, I get 4 plus 3 over 4 minus 3. That's just going to be 7. Okay, so I know that I have to find the slope, and I have my x1, y1 that I'll use at the end. We haven't done any calculus yet. Now it's time to find the derivative. So I have low is x minus 3, d high is 1, minus high, d low is 1, over low squared. And these 1s aren't doing anything for us, so I can go ahead and distribute this minus, and I'm going to get x minus 3 minus x minus 3 over low squared. Well, x minus x is 0, and negative 3 minus 3 is negative 6. So now I've found my derivative, but we need to plug in our x equals 4 to find our slope. So when I do that, I get negative 6 over 1, so our slope is negative 6. So now, if I plug my slope and our point into point-slope form, I get y minus y1 equals m times x minus x1. That would be the equation of my tangent line in point-slope form. And if I want to keep going and put it in slope-intercept form, then I will distribute the negative 6. And we'll add 7 to both sides, and I get y equals negative 6x plus 31.